11.1, yes, we do. We jump from chapter to chapter 11. This is always the chapter that we do in the middle of the section or of the semester. The reason is because we'd like to have you do a little bit more easier concepts when we do such difficult ones in second semester. So we're talking about probability. Chapter 11 is probability, and then the second test will be stats. Lucky us. There's different things that we have for probability. We have to first figure out how many different options we have before we actually get into talking about probability. So the first thing we have here is a fundamental counting principle. So an example would be if I asked you how many different ways could you match 3 pants and 2 shirts? Well, for each pant, you could wear either one shirt. So when you want to figure out the total number of ways, you take the total pants times the total shirts. So there would be 6 different outfits. Do they all look good? I don't know. But if I want to figure out how many total different options would you have, let's say for a license plate. One type of Maryland license plate has 2 letters followed by 4 digits. So how many license plates are there? So first you have to know how many letters are in the alphabet. There are 26 letters. You can have repeating letters, so there's 26 for both. How many digits? This is where people get confused. 0 through 9 are digits. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. There's 10 total digits. So if I'm going to multiply this in my calculator, 26 times 26 times 10 times 10 times 10. So how many different license plates options are there? 676,000 ways that you could have a license plate. So in 2004 and 1912, these are the 2 different types of license plates that you could have. It's asking for how many more in 2004 style license plates were possible than 1912. So first you have to figure out how many total are in 2004 and how many total are in 1912. So I want you to pause. I'm going to pause. I want you to try to do that by yourself. So this is how many in 2004. This is how many in 1912. If we were to subtract that, just taking away one number right here, 17,566,000 more ways for license plates. Well, that's good because the population is increasing. So now we're going to break it down to permutation and combination. So permutation. Permutation is when there's a particular order. Order matters. Order matters. You will hear me say, does order matter? Here are different ways that you can represent permutation. If people are finishing a race, first and second, those are different. President, vice president, secretary. President would be different than secretary. A phone number, because you're calling a different person. Again, when you have first, second, or third. If changing the order makes a difference, then it's permutation. You might want to star that. Okay? How you might calculate permutation. So when you're calculating, let's say if you have a total number, permutations P, your total number goes here. So number goes here. So total number. And the number here is how many you're picking. How many? On your calculator, you go clear that out if you want. But if you go to math, and you go over to prob, arrow over, right here, this is permutation, push enter. Let's say if I had 15 people, and I'm going to pick first, second, and third, I'm picking 3, the total number of options I have would be 2,730. Okay, so let's get into it. So, in how many ways can you file 12 distinct, so they're different folders, one after another in a drawer? So it's permutation because order matters. It's saying in a certain order, you have 12 folders, and you're picking all 12 of them. So again, we go to math. We can go over to probability. Whoopsies. Sometimes it's easier too if you type the number first, depending on your calculator. Go to math, go to probability, 12, pick 12. That's a lot of ways. So I typically, when I have a very large number like this, I first write it down and then I put in the commas. And how many ways can you arrange 8 different shirts on hangers in a closet? Again, you're picking all 8. 8, choose 8. Try to type that into your calculator right now and see what you get. You should get 40,320. It's a lot of different ways, because remember, if you had all 8 shirts in there and you just moved the first one, the second, that's a completely different way. 10 students are in a race. First, second, third win the medals. How many ways can 10 runners finish first, second, and third? No ties allowed. So I want you to try to do this one, write it up, how you should type it into your calculator, and find the answer. Be 720 different ways. Combination. So combination is when same type of thing, but order doesn't matter. If I say these 3 students go downstairs and bring up a box, it doesn't matter. If I said this student, you're in trouble, go see principal. This student, I want you to go pick up some yogurt. This student, go on a walk. That's different. So combination, does not make a difference. So picking 3 members per committee. Picking toppings on a pizza, because the way that you eat the pizza is going to be the same. A raffle when you have 5 winners and they're all the exact same. Combination still is going to look the same as permutation, is just with a C. So this is total that you're going to pick from. This is how many you're picking. How many you're picking. So if I said there's 10 students in my classroom and I'm picking 3 to go down to the office to bring up a box for me. So if I can type in the 10, that's my total. Go to math, go to probability. Now combination is this right here. So I'm going to pick 3 people. There'd be 120 different ways I could pick the 3 people. So this first one, what is the number of combinations 13 taken 4 at a time? So combination C, the total goes first. How many you're picking goes second. I could go math again. I can also go up, highlight that, push enter, and my total now is going to be 13. I'm picking 4. There's 715 ways. 715. I want you to pause and do B and C. You should have got 56 and 3003. Now we're getting into the actual which one are we dealing with. For each situation, determine if it's permutation, combination, and answer the question. The chemistry teacher divides the class into 8 groups. Each group submits 1 drawing for the molecule structure of water. She will select 4 of the drawings to display. And how many different ways can she select the drawings? Well, there's no prize here. It's just going to be displaying the project. So this would be combination. So you have to think, does order matter? You have 8 groups and you're choosing 4. Plug that into your calculator and see what you get. Should have gotten 70 different ways. For 4A, how many different ways are possible to select and arrange? So now we're talking about arranging. This one word makes a difference, the 4 drawings from left to right. So again, we already have the 4. So how many ways can you possible to arrange the 4? We have 4 drawings, we're picking 4. So now order matters. We're not doing the total of 8. And there will be 24 different ways you could arrange those. 100 students entered into a drawing. The 6 winners will get a free prom ticket. They're all getting the exact same prize. So you should try to figure out, is this permutation, combination? Be combination because they're getting the same prize. How many different ways? It's a very large number. Comma. 1,192,052,400 different ways for those 6 people. I want you to try to do D and E completely by yourself. Both of them are permutation because order matters. The prize is different here, so order matters. The position is different here, order matters. So 25 choose 3 should be 13,000, and 50 choose 3 should be 117,600. So now final little bit is this factorial. This is called factorial. What a factorial is, let's say if we have this, 5 factorial. All that is saying is a shortened way to write down 5 times 4 times 3 times 2 times 1. Whatever that answer would be. If I had 2 factorial, it would be 2 times 1. If I had 0 factorial, it would just be 0. 1 factorial is just 1. There's an easier way to do this on your calculator. Again, if I want to do 3 factorial, you could definitely type in 3 times 2 times 1. 6. Or you can type in 3, go to math, probability, you have a factorial button, which is really nice. Push enter, same answer here is 6. If you don't have that button, you can always type in, however, again, it would be long. So if again, 12, go to math, probability, 4, this very large number, 479001600. I feel like we just had that. Try to do the last one by yourself. Obviously, the bigger this number is, the larger this number will be because you're taking more numbers multiplied together. So there we go. There's 11.1 for starting off a probability. So first, figuring out the outcomes. Have a great day.